All right, here we find ourselves in chapter 2 and starting out obviously in section 2.1. And the big thing here is that we're going to be reminding ourselves about functions. Functions should have been something you studied in intermediate algebra, and nothing is going to change in terms of our definition. We just want to have more work with them. Make sure that you remember the definition of a function, domain and range of a function, and whether you have a function or not, and evaluating functions. That's what's going to be in this first section, is just kind of the core of functions. And so if we start out, let's start out by a definition. So a function is a relationship that sends each individual x value, right, or what they call the input value or the domain, to actually, let me be really careful here how I choose to word this, to only one y. And the 1 is important. And the y value is the range, right? So a function is like a machine. It takes an input, does something with it, and then spits out an output. So the first questions are all going to be about whether something's a function or not. And so they're going to tell you, hey, we're going to send A, B, C, D. So we have a relationship that takes the letters A, B, C, D and sends them to the numbers. And maybe we have the numbers 1, 2, and 3. And maybe A goes to 1, B goes to 2, C goes to 1, and D goes to 3. And the question is that a function? And so the answer to that is, well, let's check. Where does A go? Only to one value, number 1. Where does B go? Only to one value, number 2. Where does C go? Only to one value, 1. So it's okay that A and C are going to the same place, but what wouldn't be okay is if C went to 2 different places. C doesn't. C goes directly to 1, and D goes to 3. This definitely represents a function, so this is a function. The domain of the function is the set of all values A, B, C, D. And the range of the function, apologize, I mean it's the first time I'm writing domain and range. I just use a capital D and a capital R. The range would be where they get mapped to, 1, 2, 3. And so the initial questions are going to be much like that. So what would a non-function look like? You'll probably see some in the homework, right? That not everything every relationship they're going to give you will be a function, as they go through and give you different ideas. So if we looked at this, a mapping of like a father to a son, and I put my name in here, Wayne, and put another person's name in here, Brian, and then Sam. So here's the fathers and the sons. And the sons are Owen, Jack, Todd, and Ryan. And what's happening is Wayne's going to Owen, but Wayne also is going to Ryan. Brian is going to Jack, and Sam is going to Todd. Now, this is a relationship, but the relationship is not a function, and that's because Wayne is being mapped to 2 different outcomes, Owen and Ryan. So a function needs to send one input to exactly one output. And unfortunately, my one input of Wayne is going to 2 different places, which is very practical. I'm the Wayne in this, and I have 2 sons. My 2 sons' names are Owen and Brian. So that's all that means, is that I have 2 sons, and Brian just has 1 son, and Sam has 1 son. Look at the domain for just a minute. The domain is Wayne, Brian, and Sam. And the range is Owen, Jack, Todd, and Ryan. Anytime your range exceeds your domain, you have to have a non-function. So this is not a function, right, for reasons previously mentioned. But I'm just trying to show you things that are like that. So they'll do these with boxes like this. They'll do them with ordered pairs. Our job is just to decide what the domain and range is, and whether it's a function or not. So again, domain is all the inputs, the first values. The range is all the map to values, all the y values. And so they'll have us do it with this, and then also with equations as well. Let me just take a look at some of the questions that they're asking. So they do it with ordered pairs, pretty similar in that regard. And so about half the homework is doing work just like this. And then they'll give you an equation like this. They'll say, so here's my second question. Determine if y equals x squared plus 9x plus 3 is a function of x. Okay, and then we're simply marking yes or no. So remember how we tell whether something's a function. If you put in an x value, does it go to a specific place? And let's just picture what would happen. For any x value that we plug in, we'd square it first, we'd multiply it by 9, each time giving us a unique value. And then we would add 3 to both of those results. This is going to be a unique output every time. Every time you plug in an x, you're going to get out a single y. So for example, if I just pick the x value, let me not put it up high like that, sorry about that. If I pick the x value of just a random one of 3, then y would be equal to 3 squared plus 9 times 3 plus 3. Or y would be equal to 9 plus 27 plus 3. My point in showing you this is we go to a very specific y, 39. So the question could be, so this is yes, this is a function. Now we need to think about that, more in general. 3 was just arbitrarily chosen. So as we look at this, how can we tell that's a function? Honestly, we can tell right here. Whoops, I didn't mean for that to be a, I meant for that to be a highlighter right here. If you look at your y's, and your y's are single powers or cubes or something like that, if they're an odd exponent, it's going to be a function, because odd exponents represent signs. So for example, what if it wasn't an odd exponent? What if my next example that I'll make up, number 3, is y squared equaling x plus 1 a function? And the answer to that, well, if we go off of what I said, the answer is going to be a quick no, but let's look why. So what did I say? I said if y had an odd exponent on it, it was going to be a function. And that's because odd exponents there's only one thing that could be that way. But with squares, there's 2 things that we could square to get a number. So let's try the same thing. Let's let x equal 3. So with that single x equals 3, look what happens. I get y squared is equal to 4. And so what is y? You learned early on, even in Algebra 1, when you did the square root property, that when you take the square roots of both sides, let me do that in a different color, that you have to do a plus or minus. So obviously this is plus or minus 2. Well, that's a problem. 3 is being sent to both 2 and a negative 2. It is not a function. So the answer is no. That's why the even powers are a problem. However, if it was, let me just do another example to just piggyback on that, is y cubed equal to x plus 1. And then this time let me pick something like x equals 7. Okay, so now we got y cubed is equal to 7 plus 1. Y cubed is equal to 8. Well, when you take the cubed root, right, I'll do that in blue again, the cubed root respects signs, right? The cubed root of 8 only has one value. There's only one number that you can cube to get 8, and that's 2. So 7 is being sent to 2, and 7 is not unique. Why did I choose 7? Because I wanted the x plus 1 to work out to be a perfect cube. And so you're going to have questions just like this. The remainder of the homework is focusing on domain and evaluation of functions. So if we focus on domain for just a minute, there are really only two ways you get a domain restriction. So the best way to handle domain, as you should remember from Algebra 2, is basically assume everything works. Everything is in the domain. And then rule out what's not. And look for problems. Now, when do we have problems? Two ways that we have problems. We can never divide by 0. So we need to look and make sure that is there a number that's going to cause us to divide by 0. So for example, in this function, y is equal to x squared plus 2x plus 1, definitely a function. We're never going to divide by 0. It's not going to be a problem. Everything works. So most of the, I shouldn't say most of the time, but much of the time, everything works. That's why I'm saying assume everything works. So we're not going to divide by 0 in this type of problem. We're going to plug a number in for x, and it's going to be just fine. Now we do have to be a little bit careful if our function was y is equal to x over x plus 2. Now I have the potential to divide by 0, and I got to pay attention to that. So that's what I mean by never divide by 0. So we'll look for those instances where we can. And the second thing is that you can only take the even root of positive numbers. Those are really the only two ways that we get domain restrictions. So let's see what the work looks like. So the last one I did was number 4. So this one will be example 5. So consider this function. F of x is equal to x plus 2 over x squared minus 1. Okay, we're going to assume everything works, but unfortunately it doesn't, or at least it has a potential not to. I got to be careful how I say that. Let me highlight something. We need to investigate this x squared minus 1. We could care less about the top. The top being 0 is fine. If the top is 0, then the whole thing's 0, and that's fine. 0 is a legitimate output. But as you know from your previous studies, we can't divide by 0 because it's undefined. So the question really is, based upon that highlighted piece, can x squared minus 1 ever be equal to 0? Well, we know how to solve that. We've been solving that since Algebra 1. One way to do it is to factor it. Well, yeah, there's two things that could cause that to be 0. X is equal to 1 or x is equal to negative 1. So the domain is all reals except these two values, negative 1 or 1. Now they may ask for the range, or sorry, the domain in what do you call it? Interval notation. So if that's the case, we go from negative infinity all the way up to negative 1, but we don't include the negative 1. We include everything from negative 1 to 1, and then we go from 1 all the way up to infinity. Right? So we have basically just 1 and negative 1 being ruled out. And we'll write whatever they want in terms of the notation that they want. But hopefully that makes sense. You don't want to, well, let's look at another one. G of x is equal to x over x squared plus 7. Again, this has the potential, we're assuming everything works, unless x squared plus 7 could be equal to 0. Let's look at that. Can x squared plus 7 ever be equal to 0? Well, if that was the case, then x squared would have to be equal to negative 7, and this can't happen. You cannot square something and get a negative. So there are no domain restrictions, so the domain is all reals, or in interval notation, negative infinity to infinity. all of these problems that I'm doing right now should be found in probably a chapter 2 of an intermediate algebra textbook, and so they should be somewhat familiar. And let's look at another problem about domain, and we'll call that problem number 7. Here we have a function that's defined to be the square root of 4x minus 32. So we recognize that we're taking an even root, right? This is the square root. It's an even root. The even roots are square root, fourth root, sixth roots. And so if we have that, we got to remember that we can only take the even root of a positive number. Positive number or 0. Because you can take the square root of 0, so that's important for me to say. Sorry, that was a mistake before. So 4x minus 32, that needs to be greater than or equal to 0. Or 4x needs to be greater than or equal to 32. Or x needs to be greater than or equal to 8. That's your domain. You get your domain very directly, I guess is the word that I'm using. So for this to happen, we must have 4x minus 32 greater than or equal to 0. The only way that can happen is if we're picking x values that are bigger than or equal to 8. If you pick anything less than 8, we're going to have an issue because you're going to be taking the square root of a negative, which doesn't exist. So what's the domain? In interval notation? In interval notation, it's 8. I'm using the square bracket because we're including it all the way up to infinity. And that should be a reinforcement of what you had before. Awesome. The last piece in this section is function evaluation. And so I know you know how to evaluate functions, but I'll just be making sure that you understand what they're going to grab are probably most likely rational functions. That's what I saw in the homework, something like that. And they want you to find things as simple as f of 7. Right? And so nothing earth-shattering here. 7 over 49 plus 1. Or 7 over 50, and you're finished. They're going to have you find f of negative x. So f of negative x is equal to, and let me do this in blue, negative, oops. Let me do this in a stronger blue, negative x over negative x squared plus 1, right? Just putting that all in. And so what do we have out of this? We have a negative x up top and an x squared plus 1 on the bottom. Perfect. Here's something I want to point out. That's the answer to the question, but look at what this is. This is equal to negative f of x. This thing is symmetric with respect to the y-axis because when you plugged in a negative x, you got, well, I apologize. It's symmetric with respect to the origin because when you plugged in a negative x, you got a negative y out. Remember, f of x is just your y. Okay, I'm going to drop in these little hints along the way, but these are the things that we want to make be aware of. This means that this is symmetric with respect to the origin. When you plug in a negative x and get a negative y out, that is symmetric with respect to the origin. Why am I saying it's negative f of x? Because that negative can be brought out front, and it looks exactly like the original f of x. Okay, now this last part right here that I'm about to box was not part of the question. The question's answered with the f of negative x, but I want to show why they're asking that. They're going to ask for you to do something like f of x plus 1, and they want you to fully simplify it. So this is x plus 1 all over x plus 1 squared plus 1. Now what do they want to make sure? They want to make sure you're not going to cancel these x plus 1s. They want to make sure that you're disciplined enough to know that you can't cancel something over division if you have an addition going on. And so they're going to just make a better u. So what do they want us to do? They want us to expand this. X plus 1 over x squared plus 2x plus 1 plus 1, or x plus 1 all over x squared plus 2x plus 2. And we can't cancel anything, right? Because we can't factor that. There are no factors of 2 that add to be 2. Factors of 2 are only 2 and 1, and they add to be 3. Nothing factors, nothing cancels in that. The top doesn't look like the bottom. That's what they're going to have us do. Just plug in algebraic expressions to make sure that we're disciplined. the last thing they're going to do is set you up for the first part of calculus, which is the derivative. And the definition of the derivative involves something that you're about to see. So let me get a good number here. Let's make this number 9. And this will be one of our last examples. F of x is equal to negative 4x plus 5. What they want you to find is, it's going to seem weird, but it's totally based in calculus. They want you to find that. Perfect. So what are we going to do? We're going to do exactly what's there, being very, very careful. So I'm going to do my substitutions in blue. F of x plus h. Actually, let me box. Not box it. Let me highlight it in blue. I'm going to do this part right here in blue, just so you can follow. F of x plus h. Well, what is that? That's negative 4 times x plus h plus 5. I'm going to do this next part in green. Minus, and you're going to subtract anything that comes after. And what comes after is going to be in green. Negative 4x plus 5. That's the discipline that I'm talking about. Is to make sure you put in grouping symbols. You've chosen a path where you have to have a big attention to detail and write things exactly how they are. And so this is what we're looking at. We just have to simplify that. We figured out exactly what we need to do. So what do? We distribute. Negative 4x, let me fix that, minus 4h plus 5 minus, actually it's going to be a plus 4x minus 5 all over x plus h. And so what are we going to do next? We are going to simplify as much as possible. We're going to get rid of the 4x's, we're going to get rid of the 5's, and we're going to have, actually on the bottom, I knew what was bothering me. On the bottom is just h, not the x plus h, sorry. It's f of x plus h minus f of x all over h. So I'm going to fix that a little bit. Apologize, I'm like, this isn't quite right. And it's just the way I chose to copy it down when I was writing down a problem. So look what we have. We have negative 4h over h, and that's negative 4. That's what they want you to plug in there. It simplifies down a lot. And we'll talk about what this means possibly a little bit later, but certainly in your calculus class. But this is a very interesting thing to go through and do. So let's do a last example of this so I can mirror your homework really well. So f of x is equal to x squared minus 8x plus 7. And they want us to do the same thing. Find f of x plus h minus f of x all over h. I'll write it correctly this time. So what does that mean? I'll do the same thing where the first thing's in blue. Okay, that's x plus h, the quantity squared, minus 8 times x plus h, because we know what we're doing. Okay, and then this is the same minus sign that's in there, and we're going to subtract away everything that follows, which I'll put in green. And what is that? That's f of x, so I just have to recopy that. But note that it's all after the subtraction, so we need to distribute that subtraction. And then it's just being careful. X squared plus 2xh plus h squared, right, when you do the FOIL process out. Minus 8x minus 8h plus 7 minus x squared plus 8x minus 7 all over h. Now look what happens. This is why I wanted to do 2, because you can start to compare them and compare your work. Anything that doesn't have an h should go away. So the x squareds, they go away. The negative 8x has a positive 8x. The positive 7 has a negative 7. That should happen if you've done your algebra right. That'll help you catch sign errors and things like that. Now, remember, there's an h everywhere, so let's factor one out. So this is 2x plus h minus 8, and that's all over h, and the h's cancel. So you want to do as much work as you can. Where am I? Chapter 6 in Algebra 1, Chapter 6 in Algebra 2, right? Simplifying rational expressions. Pretty much we assume that you remember all your algebra, because why else would you choose an algebraic path, right? If you didn't want to just understand those ideas coming through. That's the right answer. 2x plus h minus 8 in any order. You should accept it in any order. I'll be reviewing all of your work and making sure that you get full credit for the work that you're doing. That's correct. All right. Thanks so much for watching this video. Hopefully it's very helpful.